Okay, your final thing is to make sure you can connect your equations to the slope. And here's how we do it. First, we start off and say, okay, say we got something like 3x plus, nope, strike that. Let's say we have something like y equals 2/3 x plus 5. Here's your equation, and I'm going to ask you to graph it and give me the slope of that equation. Well, when we do this, we have, we graph it just like normal. Let's get a couple of points. Stick in 0, that's the easy one to stick in. We stick in 0 for x. We have 2/3 times 0 is 0, plus 5 is 5. Y equals 5. So 0, 5 is one of them. It's kind of nice. And stick in another point. I don't know, 3. 3 is kind of a nice one. You could stick in anything you want, but 3, 2/3 times 3 is 2, plus 5 is 7. So when you graph it, you have 0, 5, 3, 7. There's your line. Now, the slope. How do we get a slope between 2 points? We're going to take m equals 7 minus 5 over 7 minus 5 over 3 minus 0, 2/3. Slope of this line is 2/3. Let's try it again. Y equals negative 7/9 x plus 18. Let's do a little graph here, a little chart, x, y. So if x is 0, y equals 18. Stick in a really good number that will get rid of that. Stick in a 9 for x. Those cancel. We have negative 7 plus 18 is, oh, that would be 11. So you can graph this. 0, 18, then 9, 11. The slope is going to be 18 minus 11 over 0 minus 9. 18 minus 11 is 7 over negative 9. That's negative 7/9. Now, we could do this over and over. And some of you will think, I think I see a pattern. Brother Bear, stop. 2/3. 2/3. Negative 7/9. Negative 7/9. Is it possible that we could skip this whole thing and I give you this? Y equals 3/8 x plus 27. Could you give me the slope of that? You're like, well, if that pattern holds in the slope, it's going to be 3/8. You are correct. If y is by itself, the slope will always be sitting right in front of the x all the time. In fact, it's so common they write it like this. They say the m is right in front of the x and they put this other thing. This number, you'll notice, was always the y-intercept. So here's the slope here. Now this is if y is by itself. The slope is there. And here's the y-intercept. So you have the slope and the intercept just sitting there in the equation. So it's called the slope-intercept form of the equation. However, you will not always be able to have them in this form. So you can do one of two things. So if you get something, 3x plus 2y equals 18. And you say, okay, let's find the slope of that line. You could go through the whole thing, get an x and a y, subtract them, and find out what that slope is. Or, since you already know that if you get y by itself, slope will be right there, you can do that. You can say, aha. So if I subtract the 3x over, why do we write the negative 3x first? I don't know. We just subtracted the 3x over. Then we divide by 2. 18 divided by 2 is 9. Can you tell me what this slope is? It's right there. So you can change it into this. Or you can start, after you do that a few times, well, let's do it one more time and then we'll see a pattern. 5x minus 8y equals 16. So, finding the slope of this, well, we can use that pattern over there. So let's subtract 5. And then divide by a negative 8. That's gone. So we have y equals 5/8 x minus 2. What's the slope? 5/8. So you look at that and you're like, oh, there's a pattern that always happens. Always. Negative 3/2. There's a 3 and there's a 2. When things are written in standard form, they are written with no fractions. That these numbers right here are integers. If you remember those are the nice ones. No fractions, no decimals, nothing. If it's written like this, we can follow this pattern. Let's do it one more time to make sure we can do it. Let's get y by itself. Subtract the ax. Notice that minus sign pops up. And divide by b. The slope will always be, I say, over b. Now you may ask, why in the world does this help us? Let's do a couple of examples. Now that we've got that. So, right here, we know a really easy point. If we stick 0 in right there, we have negative 5 as an intercept. That's automatically one point that's really, really easy to get. Now, we also know that the slope is 3/8. So on that top one, the slope is right in front of the x because the y is by itself. So that means from this point, we could go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's the next point. You don't even have to know what it is exactly. I mean, we could find out if you go up 3, you're at negative 2, and you're over 8, so 8, negative 2 is the point. But that's how steep it is. If you have a point and you know how steep it is, that gives you the entire line. So you're able to use that to graph a line kind of fast. Let's do another one. Y equals negative 2x plus 5. Okay, so really quick, if you stick a 0 in, get 5. That's why slope-intercept is so nice. There's the intercept right there. And the slope is negative 2. Now, any number can go over 1. So it's negative 2 over 1. And you have 0, 5. Now, this means it goes down 2 for every 1 it goes across. You can go down 2, 1 across. And there's your line. So it actually goes kind of fast. Now, some of you may think, oh, so I go up 2, but then you have to make sure and go back 1. Either way, you'll get the same line. When you're dealing with the negative only goes on either the top or the bottom. If you put a negative on both of them, it would cancel and you'd have a positive slope. But this is a negative one going down. Let's do a couple with this standard form that's a little bit harder to pull stuff out of in some regards. So we have 5x plus 3y equals 2. Now you'll notice it's not really easy. The intercept doesn't just pop out at you. You have to think about what problem might be good. In this case, you know that 5 minus 3 is 1, so we could have a point. If we took 1 minus 1, that would give us an x and a y that would work. So there's a point. We found one. Now the slope. If you look at this, anytime you have a number in front of x and a number in front of y, the slope is the opposite of the first over the second. So the slope is a negative 5/3. And that's the shortcut. Now you could change this into slope-intercept and it would work fine. So we have 1, negative 1, and the slope from here is down 5 over 3. Oops. There we go. Alrighty, let's try another one very similar to that. minus. Okay. So, we need to get a point first. The y-intercept isn't so nice. The good thing about standard form is you're able to pull out the x-intercept really easy if you'd like to. Stick a 0 in for y. If that's gone, can you get x by itself? X is 4. 4 times 4 gives you 16. And the slope is the opposite of 4 over negative 7. So that means we have positive 4/7. So 4, 0, and up 4 over 7. There we go. So you're able to graph lines fairly quickly if you can pull the slope out of the equation fast. All you have to do is find one point and you're able to graph the other ones.